Alright guys, welcome back to another video, and today we'll be going over lesson 2 actually, which is simplifying radical expressions. And so we have a few questions here that we're going to try to get through, and yeah, that's basically it. The best way to learn is to try out some examples. So now that we've gone through the laws and rules of how to use these, or how to solve for these, we're going to now try to solve them. So yeah, let's do this. So our first question is square root of 180. So just a quick reminder guys, I know I've done this in other videos, just to reiterate it again. So whenever I have a squirt or SQRT, that always means square root. So square root and then whatever is inside the parentheses. This is basically saying the square root of 180. So yeah, so let's do this then. So first we want to separate them into two of the basically the greatest common factor, or something that you can basically simplify even more, right? So like a perfect square basically. So what are two numbers that multiply and equal 180 that are good members of this? Wouldn't 36 and 5 work? So we could do squirt 36 times the squirt of 5, and so this would equal 6, right? Because square root of 36 is always 6, and then 6 times the square root of 5, right? Because you can't simplify that anymore. So this should be your answer, 6 times the square root of 5. So let's go to the next one now. So we have the square root of 192. So let's see, what numbers can we multiply to find the square root of 192? So we do have like one number that we could use is if we could use 4 and 48, right? Another number we could use is 16 and 12. So let's do 16 and 12. So square root of 16 times the square root of 12, and this, so square root of 16 is obviously 4 times the square root of 12, right? From the square root of 12 you can go even further, right? So that's the square root of 4 times square root of 3. Square root of 4, like we said, is 2. So this will be 4 times 2 times the square root of 3, right? So this will equal, 4 times 2 is 8, so you'll have 8 square root of 3. This will be the answer, 8 square root of 3. So let's go to the next one. So these are all like basically the same, just like finding the square root of one basic number. They should be pretty simple. So now let's go to the next one. So we have 384. Well, let's see what we can do. Could we use 16? Well, if we multiply 16 into there, we would have 16 and 4. Right? Now, 16 and 14. Let's see. 16 and 14. Alright, so from here, what you would do is, so obviously you would put them into the different forms. So you'd have square root of 16 times square root of 24. Oh, I think I might have said square root of 14 earlier. So in case I did say that, just make sure guys that it's the square root of 24. I don't know why I decided to say square root of 14. That's my bad. Square root of 24. So this is equal to 4 times the square root of 24, right? 24 you can do 6 and 4, and obviously square root of 4 is 2. So again, times 2, and then the square root of 6. And so from here we have 8 times the square root of 6. And then don't forget the 2 over here in the very first problem, so you have to multiply the 2 over here. So this is equal to 16 square root 6. Oops. Yeah, there we go. 16 square root 6. Alright, now that we've got those practice problems, let's do a few challenge problems now. With variables actually. So square root of 50 x to the power of 3 times y to the power of 2. Alright, let's do this. So first of all, right, let's think, is there any way we can find the square root of 50? Well, you can, right? You have the square root of 5 and 2, or not 5 and 2, square root of 25 and 2. So square root of 25 is 5, right? So this is basically 5 square root of 2. But you have the x to the power of 3 and y to the power of 2, right? So what would you do here? Well, x to the power of 3, right? Isn't it the same thing? So Here, let me write this down. X to the power of 3 is the exact same thing as x times x times x, right? So x times x, well, that's x squared, right? So x times x, that is x squared. So x squared, square root of x squared is x, right? So you'll have x root x. So you'll put the x outside of the square root, and then you'll have another x in the square root. Let's look at y to the power of 2. Y to the power of 2 squared is just y. So you'll just add that outside. So 5xy times the square root of 2x. Bold that. And then our last problem is a cube root question. This is going to be interesting. So let's see. We have a cube root question, right? And let's see what types of what numbers that we can use to help dissect it, right? So we have cube root. Let's say we use 3, right? We have 3 and 54. Would 3 and 54 work? I don't think so. So let's keep looking. What other cube roots do we know, right? Well, 8 is a cube root, but that doesn't factor into this. So let's see. Does 9? No. 10? No. 11, 12, 13, 14, 15, 18, 19, 20, 21. Or how about let's try 27. That's another number that I found into mind. So if we do 162 divided by 27, we get 6. So we can use that, right? So the cube root of 127, or cube root of 162 is equal to the cube root of 27 times the cube root of 6. Cube root of 27 is 3, so that's the 3 times the, let's say, c root. I don't think that's the right abbreviation, but or crute. So that the root of 6. So cube root 3 times cube root of 6, and then we have x to the power of 6, y to the power of 4. So let's do the same thing that we did for the other ones to solve for the variables. So we have x to the power of 6 is equal to x times x times x times x times x times x. So from here, cube root, right? So we have 3 over here. So how do you write this? X to the power of 3 times x to the power of 3. So square root of, cube root, so you'll have x on both sides. So you'll have x squared. 3x squared, cube root of 6, and then we have the y to the power of 4, so that's just 4y's. So we'll have 1y here and then 1y here, right? Because 3y times y times y, take the cube root of that, you get 1y, and then you have 1 extra y remaining, so you'll have 6y inside the cube root. So I guess that's basically the end. Those are the 5 problems that we solved. 5, yeah. So those are 5 quick practice problems that we did. Hopefully this will give you a better sense of how to solve and simplify radical expressions. If you guys really wanted to, you could literally solve this by like putting the calculator square root of 5, then multiply by 6, things like that. But it's your guys' choice. You obviously can't solve for the ones with variables, but only simplify to a simplified expression. But yeah, guys, hopefully you guys found this lesson interesting and helpful. And so next lesson will be lesson 3, and that'll be adding, subtracting, multiplying, and dividing radical expressions. So basically using the order of operations, or you could just see operations because we're not doing exponents. So you can just do operations on radical expressions. So that'll be the next lesson, lesson 3. And I look forward to making that one, and I'll see you guys in the next video.